We have known how to obtain ABFS. We have known how to perform the pivot. So now let's talk about transportation simplex, the entire algorithm. The first step, make sure that your transportation problem is already a balanced transportation problem. Second step, use one of the methods to find ABFS. So use one of these three methods that you've seen before to find the BFS. So these two steps, you already know how to do that. In this video, I'm going to talk about the step 3 and step 4, but you have seen some part of the step 4 in the previous video. So at the end of the step 4, we're going to do the pivot, which has been explained in the previous video. And then the simplex algorithm actually will just keep doing the step 3 and step 4, step 3 and step 4 until we conclude that the solution or the BFS is already optimal. Okay, so this video will mainly talk about step 3 and step 4. One note here for a maximization problem, it's exactly the same with these 5 steps, except that in step 4, if minimization, the sign is less than or equal to 0 for all non-basic. For the maximization problem, it's greater than or equal to 0 for all non-basic variable. Okay, so just keep this in mind if you happen to face a maximization problem, but other than that, everything is the same. Let's start talking about the step 3 in that algorithm. First, we go back by recalling the simplex algorithm that we used to solve the linear programming problem. In the simplex table, we look at the row 0 to determine whether the current BFS is already optimal or not. If it is not optimal, then we should determine which non-basic variable should enter the basis, right? And then you can also recall that you have learned that the formula to calculate the value of an entry in row 0 for a variable is using this formula. So for example, if our variable is xij, then the coefficient of xij in row 0 equals CBVB inverse times aij minus cij. So the cij bar here shows that this is the value of the variable xij in row 0 of the simplex table. In the transportation problem, we have m supply constraints and n demand constraints. So inside the CBVB inverse vector, we should have m plus n elements, right? However, in the transportation problem, remember we may omit one of the constraints in the problem, any of them, we may omit one of them, and it will still be satisfied. Remember, this is also the reason why we only need m plus n minus 1 basic variables. So in this case, we just assume that we omit the first supply constraints. So that's why you see here we start from u2 up to um, but v1 up to vn. So we have m plus n minus 1 elements inside the CBV B inverse vector. Now let's say we would like to calculate the C hat 1, 1. So the C hat for the variable x11. So x11 is corresponding to the cell, right? Use this formula, CBVB inverse. So this is our CBVB inverse. This is our A11. So the coefficient of x11 in the original problem. And then the Cij is 8 because the cost of transporting one item from supplier 1 to demand point 1 is $8 or something. Okay, and then if you do this, you will get that C hat 1, 1 equals V1 minus 8, and it must be equal to 0. The reason is that if you remember, in the row 0 of a simplex table, if you have a basic variable, then the value of the row 0 of that variable is 0. Okay, let me repeat. If you have a basic variable, then the value or the coefficient of that variable in the simplex table in the row 0 equals 0. Now, if you wonder where or how can you get this A11 column vector, well, you need to go back to the linear programming formulation of this transportation problem. And then because we're talking about x11, so you just look at the coefficient of x11. So it appears in the first constraint, never appear in the second, never appear in the third, appear again in the fourth constraint, never appear on the fifth, sixth, and seventh. But because we omit the first supply constraints, now the coefficient for x11 becomes 0 because it does not appear in this constraint, 0 again because it does not appear here, 1 because it appears here with the coefficient 1, and then 0, 0, 0. So that's how you read x11 from the linear programming formulation. If you go back to the procedure of the transportation simplex in step 3, it says that for all basic variables, we need to calculate the C hat ij. So we need to calculate C hat 1, 1, C hat 2, 1, C hat 2, 2, C hat 2, 3, all the way until C hat 3, 3, and C hat 3, 4, because they are all the basic variables for this BFS. Okay, and then all of them must equal to 0 because they are all basic variables. And then once you have done this, you can see that there is a pattern. The pattern is for any Cij, let's say C34, C hat 34, the pattern becomes U3 V4 minus C34. Let's check another again for C21, C hat 21. C hat 21 equals U2 plus V1 minus C21. Okay, so apparently that is the pattern here. So Cij equals Ui plus Vj minus Cij. Now, using this pattern, we can conclude that for the first one, Ui or U1 in this case equals 0. So 0 plus V1 minus 8 equals 0. So that's how we know that U1 equals 0. Once you have obtained all those equations for C hat for all basic variables and set them all equal 0, then you wonder what to do with all those equations. Well, what you need to do is that solving all those equations to obtain all the u's and all the v's. So u1, u2, u3, and v1, v2, v3 up to v4. But let me show you kind of an easier way to do that by using the table, because we can visualize the table, so usually it's easier to do it this way. Okay, so this is what we get from the previous slide, that C hat ij for the basic variables equals 0, and they have the pattern of ui plus vj minus cij. Okay, because the cij hat equals 0 and this equals 0, so I just move cij to the right hand side, and now we have this relation, ui plus vj equals cij. So first thing first, from the previous slide, you know that ui equals 0. So write this down for the very first thing, ui equals 0. Now check which basic variable you can use such that you can perform this equation here, ui plus vj equals cij. Well, ui, you can use u1 and then use the j j equals 1 as well. So you can use C11, right? So ui plus v1 equals 8. And then you know that ui equals 0, so you know that v1 equals 8. And then think about again which basic variable you may use at this moment. So we may use this variable. Why? Because then you may use C21 to write down this equation. U2 plus V1 that we already know equals C21, which is equal 9. So U2 plus 8, because V1 equals 8, U2 plus 8 equals 9. Now we know U2 equals 1. When we know U2, then you can see that we can use this thing here, C22, to answer V2. So U2 plus V2 equals C22, which is 12. And then you already know from here U2 equals 1. So you know now V2 equals 11. And then we can still use U2 to answer V3, because U2 plus V3 equals C23. And then we can do that because x23 is a basic variable. Okay, so U2 plus V3 equals 13, and you know that U2 equals 1, so V3 equals 12. Now from V3, use these basic variables here. Basic variable that, and then C34. Now you can say U3 plus V3 equals C34. In other words, U3 plus 12, so 12 comes from here, equals 16. So now you know U3 equals 4. Finally, using this basic variable, you can write down the relation U3 plus V4 equals 5. So U3 equals 4. From this answer, 4 plus V4 equals 5. So V4 equals 1. So now you have obtained all the U's and all the V's. So that's how you do the step 3. Use the fact that U1 equals 0, and then the relation UI plus VJ equals CIJ for all basic variables to find the U1, U2 up to Vn. Remember that you always set U1 equals 0. So that is how we perform the step 3. Now we are going on to step 4, and then make sure you notice here that step 3 is all about basic variables, but step 4 is all about non-basic variables. So what we are going to do in step 4 is that for all non-basic variables, we are going to check if ui plus vj minus cij is already less than or equal to 0. If that is the case, then we have got an optimal BFS. If that is not the case, then our current solution is not optimal yet. Okay, please remember that we check this condition only for non-basic variables, because for the basic variables, it must equal exactly 0, which we have done in step 3. So for non-basic variables, you just check whether this thing here, ui plus vj minus cij, are they all less than or equal to 0 for the minimization case? Are they all less than or equal to 0 for all non-basic variables? So for example, c hat 1, 2 equals u1 plus v2 minus c12, and it is equal 5. And then do the same thing for all non-basic variables. Let's say you calculate c hat for c hat 3, 2. C hat 3, 2 equals u3, which is 4, plus v2, which is equals 11, and minus 9, and now the result is 6. And then out of all these non-basic variables, you see that there is still a positive Cij hat. So for this case, our BFS is not optimal yet. And then we pick this one, the most positive one, to become the entering variable. Now, once you know which variable must become the entering variable, what you need to do is actually just performing the pivoting procedure that has been explained in the previous video. So up to here, we actually have completed learning all the things that we need to know to perform all the steps in this transportation simplex. Okay, starting from balancing the problem, finding the initial BFS, and then for all basic variables, we find the U's and the J's, and then for all non-basic variables, we check whether they are all less than or equal to 0 for minimization problem. If yes, it is optimal. If not, we are performing the pivoting procedure. And then once we've done that pivoting procedure, we go back to step 3. So that's all we need to know to perform the transportation simplex. In the next video, I'm going to go through an example to really show you all the steps that we need to do to solve one transportation problem. So see you on the next one, and thank you.